Hello children, metals and non-metals. Class 8, Subject Science, Chapter 4, and this is the part 1. So metals and non-metals. So these are the few points as an introduction which you already know. So we know that all substances are made of identical building blocks called molecules, and molecules are composed of one or more elements bonded together. So elements cannot be split into simpler substances by chemical methods. And the third point is there are only about 100 elements, but by different combinations they produce such a large variety of molecules of different substances. Okay, so there are only 100 elements which are found. So elements can be further classified as metals, non-metals and metalloids, which we shall be discussing in today's class. So in this video, we discuss the physical and chemical properties of these categories and discuss their uses. So first, let us discuss about the physical properties of metals, which are very important. Okay, so here we have got the 4 columns: property, meaning, details and examples. So first property is state of matter. So all the metals at room temperature are solids except mercury is a liquid. Okay, so usually the metals are solids at room temperature. Only the liquid metal which is present is mercury. And where do we find mercury? We find mercury in thermometers, right? So you all have seen that. So detail is metals have generally higher melting points than non-metals. Next comes the property, hardness. So whether it is hard or whether it is soft, that will be the hardness property. So meaning is all metals are hard except sodium and potassium. Okay, usually the metals are solids at room temperature and the metals are hard, okay, except sodium and potassium. So the only metals which are soft is sodium and potassium. You know, that is so soft that it can be cut with a knife. Is it clear, children? So 2 properties we have studied. We have studied about the state of matter and we have studied about the hardness. And the third point is lustrous. So what do we understand by lustrous? Luster means shine. So metals are lustrous, means metals usually shine. Okay. So fourth point is malleability. So malleable means it can be beaten into thin sheets. So if any substance can be beaten into thin sheets, then it is said to be a metal. Okay, like an iron nail can be beaten to become flat, element most malleable is gold, which means you can give any shape to gold. They can be hammered or pressed permanently out of shape without breaking or cracking. Next, the fourth is done. The fifth point is ductility. So ductility means which can be drawn into thin wires. Okay, if any substances can be drawn into thin wires, then we say that it has ductile property or it is ductility. So aluminium, copper and iron are used for wires. Okay. Next property is sonorous property, which makes ringing sound. So alloys of metals are used for making bells. So have you all seen the bells in the temples and all? Yes. So we use metals in order to make the bells. Why? Because they are sonorous. And good conductors of heat. One end of a metal spoon kept in fire makes the other end hot. Yes or no? Did you all observe this? Yes. When you are cooking, if you keep spoon, then what happens? The other end will be hot. Why is it happening? Because spoon is a good conductor of heat, which means the metals are good conductor of heat. Only then it can pass the hotness in the metal. Therefore, what happens? A metallic pan has a non-metal handle like plastic or wood. And good conductor of electricity, which means if a voltage is applied across a metallic wire, electric current flows. So if it can pass the electric current to flow through it, then it is called as good conductor of electricity. So metallic wires are used extensively in homes and for transmission lines from generators. And next comes the density, more mass per unit volume. Iridium is the highest density metal. So these are the few physical properties of metals. Next comes the chemical properties. So metals are characterized by a one electron in the outermost shell like lithium, sodium, etc. or only a few electrons. Hence they have a tendency to lose these electrons and become positive ions while forming compounds. So the metals are called electropositive. So this we have already studied, right? So what happens when outermost shell has less number of electrons or one electron, then it has a tendency to lose electron instead of gaining an electron. Okay, it is easy to lose an electron. So hence it forms a positive ion and therefore the metals are called electropositive. The non-metals lack just a few electrons to reach a stable shell configuration of electrons. As an example, chlorine atom has 7 electrons in the outermost shell and would accept an electron. See, when you have 7 electrons in the outermost shell, what happens? Instead of losing 7 electrons to become stable, it would accept an electron in order to become a chloride ion. Okay, rather than losing 7 electrons, it is preferable to gain an electron. So it is an example of non-metals. The electrostatic attraction between Na plus and Cl minus forms the ionic bond, the molecule of NaCl, that is the common salt is formed. Next, metals reaction with oxygen. So sodium and potassium react with oxygen vigorously at room temperature. Okay, so if you keep that sodium and potassium in the oxygen, what happens? It reacts vigorously, it reacts rapidly. And magnesium burns in oxygen on heating and produces a dazzling white flame and forms a white powder of magnesium oxide. This we have seen in science lab. Yes or no? So when you burn magnesium ribbon, what happens? A white color flame is being produced. The erosion of the top layer of the metal by the action of moisture and air is called corrosion. So you all are aware of corrosion, right? Like metals like iron and copper corrode in moist air. So you have heard of the rusting of iron, right? So when oxygen comes in contact with that air, moisture, water, then what happens? The rusting happens. So copper when left in open develops a greenish layer. So that is the reaction. And corrosion of iron is called rusting. So rusting causes vast damage to the metal, thereby weakening the structure. Next few important reactions here. Metals react with water to form oxides and hydroxides along with hydrogen. Like sodium, potassium and calcium react vigorously with cold water, whereas magnesium reacts with steam or hot water. So metals react with acids and liberate hydrogen gas that burns with a pop sound. Okay, you have to remember this, children. Whenever metals react with acids, they liberate a hydrogen gas and produces a pop sound. You will hear some sound like pop. Okay, so metals do react with acids. Copper does not react with dilute hydrochloric acid and even on heating, but it reacts with sulfuric acid. Oxides of metals are usually basic in nature. These basic oxides react with water to form bases which turn red litmus to blue. Metals, the uses of metals. Metals are used in making machinery, automobiles, industrial gadgets, cooking utensils, water boilers, etc. So silver foil is used for decorating sweets, while aluminium foil is used for wrapping food. Yes, you all have seen. Iron is used to make pipes, sinks, storage tanks, railings, cylinders. And next, copper is used to make heating utensils, car radiators and calorimeters. Aluminum alloys are used to make bodies and engines of airplanes. Zinc is used in dry cells. Mercury is used in thermometers. Silver and gold are used to make ornaments. Chromium and nickel are used for electroplating and manufacturing stainless steel. So these are the few uses of metals. So what we learnt in today's class, we have studied about the physical properties of metals, chemical properties of metals and the uses of metals. So these are the few questions that you have to answer. Thank you, children.